Okay, now here we go. We're talking about distance this time. Now distance is actually how far it is from one thing to the next. Not where it's at, but how far away it is from each other. For example, what is the distance of AB? So if I'm standing here at A and I want to walk over to B, how many steps do I have to take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need to take 10 steps if I want to get from A to B. Remember, distance is always positive. So the way to figure that out is you take the first number and subtract the second number, and then it's always absolute value. So you put it inside the bars to always be positive. So for example, the distance from -3, so if I'm standing here at 3 and I want to walk to 9, how many steps would I take? Well, you could count them again, because that's real easy to do when you're vertical or horizontal. But it's faster if you just subtract the numbers. So -3 minus 9, and then take the absolute value. -3 minus 9 is -12. The absolute value of -12 is just 12. So the distance from -3 to +9 is 12 steps. Find the length from A to B. Well, A is at -6, B is at 4. So if I use this formula, -6 minus 4, and I take the absolute value, I get -10. And the absolute value of -10 is 10 because it's always positive. So to go from A to B, you would take 10 steps. Okay, now when we find the distance on a coordinate plane, it is a little bit different. But the first way we're going to do it is by Pythagorean Theorem, because we're all very familiar with Pythagorean Theorem. So the first thing we're going to do here is we're going to plot these points. 1, 2, 3, 4, 5, 1, 2. So there's A. And -3, 1, 2, 3, 1, 2. And there's B. Notice when you connect them, they're horizontal just like the number line. So we're just going to count the spaces. 1, 2, 3, 4, 5, 6, 7, 8. So to go from B to A is only 8. So the distance from B to A is 8. Okay, what about this one? -3, 1, 2, 3, 1, 2. So there's C. And -3, 4. 1, 2, 3, 1, 2, 3, 4. So there's point D. And when I connect them, notice they're vertical. So anytime they're horizontal or vertical, straight up and down, all you have to do is count the spaces. So I'm going to go 1, 2, 3, 4, 5, 6. So I only got to count 6 spaces. So to go from C to D is 6 steps. So anytime you're horizontal or vertical, so horizontal or vertical, just count your steps. So just count your steps. Okay, now this one is going to be a little bit different. So let's plot the point. -3, 1, 2, 3, -2. So there's point E. And then 3, 2, 1, 2, 3, 1, 2. So there's point F. Now when I connect these, it's not horizontal or vertical, so I have to use a different method. So what I'm going to do is I'm going to draw a right triangle. So if I start here, and that's not the one I want to use. So let's delete that one, makes too big of a point. All right, so let's go back. All right, so I'm just going to make a right triangle. So from here to here, and then from here to here. So notice I've created a right triangle. So I'm just going to count. Now I can count the vertical and the horizontal. So now I've got 1, 2, 3, 4. So this one is 4. 1, 2, 3, 4, 5, 6. This one is 6. So now that I have a right triangle, I can use Pythagorean Theorem. So this would be my hypotenuse, so that would be my C. So A squared plus B squared equals C squared. So 4 squared plus 6 squared equals C squared. 16 plus 36 is 52. And then we always take the square root in the end. So the square root of 52 is 7.2. So it is 7.2 units from E to F. So I'm going to put 7.2 units. All right. Let's try it again, and let's see what happens. So negative 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So there is point G. And negative 1, 3. So negative 1, 1, 2, 3. So there's point H. So I want to know how far is it from here to here. So I'm going to draw that little right triangle. So I'm going to go down 1, and I'm going to go over that many. So let's see how many that many is. So we went down 1. 1, 2, 3, 4. So that's 4. So that means 1 squared, because we've got a squared plus b squared equals c squared. So 1 squared plus 4 squared equals c squared. 1 plus 16, that's 17. And then I'm just going to take the square root of both sides, and I get that my answer is 4.1. So from G to H is 4.1 units. All right, now what is it from R to S? So let's connect R and S. So here's R to S. And then let's draw a right triangle. So I'm going to go this way. And you could go down if you want. You could go this way and this way. It doesn't matter. It's the same thing. So this piece is 2 units. And then we've got, let's see, 1, 2, 3, 4, 5, 6 units. So that one is 6 units. So let's see what happened to my pen here. All right. So this one is 6 units. So now I'm going to use Pythagorean Theorem again. So I've got 2 squared plus 6 squared equals c squared. 4 plus 36 equals c squared. 40 equals c squared. Again, I'm going to take the square root of both sides, and I get about 6.3 is my c. So the distance from R to S is about 6.3 units. Now sometimes you get this really small graph, and then I'll give you really big numbers, and they don't fit on the graph. So what happens then? You can't plot the ordered pairs. So then you're going to have to use what's called the distance formula. And again, you'll label your points and just plug and chug. So here's the distance formula. It's on your formula chart. I'm going to rewrite it because this is kind of blurry. So the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And that goes in there. So using the distance formula, find the distance between these 2 points. Round to the nearest tenth. So we'll round to 1 decimal place if we need to. So let's label these points. So we've got x1, y1, x2, y2. So using the formula, I'm going to write it down. So x2 minus x1 squared plus y2 minus y1 squared. You don't have to memorize this, so don't freak out. It's on your formula chart. So x2 is 13 minus x1 is negative 14 squared plus y2 is 5 minus y1 is negative 1 squared. 2 negatives make a positive, so this becomes 27 squared plus 2 negatives still make a positive, so this becomes 6 squared. 27 squared is 729. 6 squared is 36. So I'm just going to add those two numbers together, and I get 765. So the square root of 765. So just type that in your calculator, and you're going to get that the length is 27.7 units. All right. Number 17. This is the last one. We'll do We'll do the application pieces, the next 4 questions. We'll do those in class as review. All right, so using this formula again, I'm going to label my points x1, y1, x2, y2. So I'm just going to plug and chug. So the formula says x2, which is 5, minus x1, which is 12. And then I'm going to square it. Plus y2, which is negative 6, minus y1, which is 10. And then I've got to square that also. So 5 minus 12 is negative 7. Plus negative 6 minus 10 is negative 16 squared. So now, negative 7 squared, that means negative 7 times negative 7, so that's 49. Negative 16 squared is 256. So just add those two numbers together, you get 305. Take the square root of 305 in the calculator and you get 17.5. So the length or the distance from point R to point S is 17.5 units. All right, so starting on this page tomorrow, we'll do some of the practice problems together in class and we'll take care of our activities. Have fun. See you then.